One of the first things I want to talk about is randomization. And this is a concept that we're super familiar with. Randomization is really, really important when we want to create computer programs that have a degree of unpredictability. Now, the biggest category of that is, of course, games, right? Can you imagine if you had to play Tetris and every single time the block that fell down was like predictable? You always knew that it was going to be a T and then it was going to be an L. Like, there would be no fun in that, right? So, how do we create this randomness for our programs? Now, in nature and in our everyday lives, it's really easy to create randomness. If you splash some paint on a canvas, that's going to be pretty random. If you take a look at the TV static from the analog TVs, that's also a whole bunch of randomness there. But when we're talking about computers, then these machines are what we would call deterministic. They will perform repeatable actions in a fully predictable way. So, how do we wrangle these machines that operate basically on ones and zeros to get them to create some random numbers? Well, there's a whole bunch of maths that can be applied to create what are called pseudo-random number generators. And the one that Python uses is something called the Mersenne twister. And if you really want to read about it, then you can have a look on Wikipedia and take a look under the algorithmic detail. But to be honest, it's a little bit too much information for anybody, unless you're really interested in these types of number generators. But what I recommend though is a free video from the Khan Academy where they explain pseudo-random number generators, and it's really well produced and it tells you a lot of different aspects of pseudo-random number generation. So have a look at that if you're interested to learn a little bit more about pseudo-random number generators. We've talked a lot about randomness, but let's see it in action. Let's write some code and produce some random numbers. Head over to the DAY4 starting REPL and then go ahead and fork your own copy. We know that we want to get hold of some random numbers, but we don't really want to implement the Mersenne twister ourselves because it's horrendously complicated using lots and lots of maths and probably will take us months to write the code for. So how can we get random numbers? If you think about it, it's a little bit like searching for something in Google. The Google algorithm is horrendously complicated and it's taken them years and years to refine and perfect to such an extent where I think Google knows me better than myself, because when I search for something, it always gives me the most relevant results. And if you're questioning the complexity of the Google algorithm, just go to Bing and try searching for something and see how relevant the results are. So they have this super complex algorithm, which we're never going to get a chance to see, let alone understand. And yet, every day we're able to search things on Google and use this Google algorithm to get the things that we want, like the airspeed velocity of a laden swallow. Now we can do the same thing when we want to generate random numbers. Because this is such frequently needed functionality, the Python team have already created a random module. So if you head over to askpython.com and search for the Python random module, then you'll be able to see the documentation for this random module. And you can see that it contains a whole bunch of functions that you can use that allows you to generate random integers, so random whole numbers or random floating point numbers. So let's see how we can tap into this random module. In order to tap into the random module, we first have to import it. So we write import random. And now we're able to use this random module in our main.python code. We can start using the documentation to generate a random integer. For example, they show us in the code snippet here that we could generate a random integer by using the randint function, providing an a and b, and it'll return a random integer between a and b, including both of those numbers. And there's even a little bit of code snippet to show us how it's done. So this line of code generates a random whole number between 100 and 200 and including those two numbers. So it could be anything between those two numbers. So let's see if we can implement this in our code. Let's say that we want to create a random integer and we use the same code that we saw in the code snippet. We say random That's tapping into this module here, dot rand int, and then we add a set of parentheses, and then we specify the start, comma, and then the end. So this is basically a range of numbers that we're specifying, any integer between 1 and 10. And now we can go ahead and print our random integer, just like that. And every single time I run it, you'll notice that I'll get a different number, or maybe sometimes the same, but it's a random number between the range that I've specified. Now, I've mentioned that the random module is a Python module. So what exactly is a module? Well, you've seen that we've mostly been writing our code all on the same page in a sort of script style, right? And everything just kind of gets executed from top to bottom. But sometimes your code will get so long because you're trying to create something complicated, and it's no longer possible to understand what's going on in such a large piece of code. What people will do in that case is to split the code up into individual modules, where each module is responsible for a different bit of functionality of your program. And if you have a complex project with many, many modules, then you could have collaboration on your project, right? Lots of people could be working on it, each person working on a different thing. Say if a factory was building a car, it wouldn't make sense for one person to build the entire car, from wheels to axles to the chassis. That's crazy. Instead, you have different people working on different modules, like the tire module, or the chassis module, or the engine module. And then once they put everything together, you end up with the final car, or in our case, the final program. So we know that the random module is a module that the Python team created to make it easier for us to generate our random numbers without needing to get into the complexities of all of the math that's required to generate pseudo-random numbers. But how can we create our own modules, and how do modules work anyways? Well, it's actually very simple. If you go ahead and click on the files icon, you can see we currently only have one file that we're writing in, which is main.py, the Python file. And the main.py is the entry point to our program. This is the file that will be executed when we run our code. Now, if I go ahead and click on this icon to add a new file, let's say I call it mymodule.py, and I create a new Python file. And inside my module, I'm going to maybe work on something else. Let's say I wanted to store the value of pi. Okay, I think that's all I remember. So I know the value of pi, and I want to be able to use it in my different programs. Now that I've created my module.py, well, now I can use my module wherever I want just by importing it. So I could import my module. And now down here, I can say, let's go ahead and print my module.py. And now if I go ahead and comment out this code and hit run, then you'll see we get that value of pi that got dragged in because I imported my module. But now we've got our code separated out into separate modules that are responsible for different things. And that is how the random module works as well. So I'm going to go ahead and delete all of this stuff relating to pi, but you can keep yours if you want to keep it for reference. Coming back to creating random numbers, we've seen how we can create random whole numbers, but what if I wanted to create a random floating point number? Well, it tells me how to do it in the Python documentation, and all I have to do is use the random module that contains the random function, and it will return a random floating point number between 0 and 1. But it's really important to note that in this case, it doesn't actually include 1. So it goes up to like 0.9999999, but not including 1. Let's go ahead and try that out. So we'll say random float equals random.random and then a set of parentheses. And this will give me output some sort of number in the interval between 0 and 1, but not including 1. So let's go ahead and see if it works. first we print a random integer between 1 and 10, and then we print our random float between 0 and 1. And every time we run the code, you'll notice that we get different random numbers. Now, here's a question. This random function always generates a number between 0 and 1, and it has many decimal places. But what if I wanted a random floating point number between 0 and 5? How might we do that? Now, it's not as complicated as you think it is, and you'll be able to do it just by looking at the code you've got here. Have a think about it and see if you can come up with the answer. I'll go through it with you afterwards. Pause the video now and give that a go. Alright, so we know that this random float can be anything between 0.00000 to 0.9999, effectively repeating, right? Now, what if we were able to multiply this random number by a number? Let's say that I multiply the random float by 5. Well, what if this random float was 0.1? Well, 0.1 times 5 would be 0.5. But what if the random float was 0.4? 0.4 times 5 would be 2. Or what if it was 0.9? 0.9 times 5 is 4.5. So effectively, by multiplying this random float by 5, I will end up with random numbers, but of course they're now floats, right? So it could be 0.000 ... all the way to 4.99999 and etc. etc. So this is how we can expand that range from 0 to 1 all the way to 0 to 5, but not including 5. So what can you do with random numbers? Well, if we think back to our love calculator that we made in the last lesson, it's kind of based on pseudoscience, right? Like, just because you have a certain number of letters that exists in the word true and love, it doesn't mean that you're actually going to be more compatible. I'm sorry to break anyone's heart out there, but if it's random anyways, then why don't we just use a random number generator, saving ourselves all of that trouble from counting T's and counting U's. We can instead just simply say love score equals random dot random int between 1 and 100, and then go ahead and just print your love score is. And then let's insert our love score and turn this into an F string. Let's print that. And you can see that we're getting a different love score every single time I run this code. It's between 1 and 100. And, who can tell that this is any different from the previous method, right? So we can use our random number generator for this. We can use it for creating a dice or flipping a coin, or we can use it in games that we create. If you head over to the next lesson, I've got a code challenge for you where you're going to be building a program in order to pick from heads or tails and help the user out when they don't have access to a coin. For all of that and more, I'll see you on the next lesson. You can find the code exercise and you want to click on the one that's day 4.1, heads or tails. Now, this is what you should start out with. There's a little bit of starting code, which you should try to not change. And the idea is that you're going to create basically a virtual coin toss program so that when you run the code, it should give you tails or heads depending on which random number was generated. Now, a really important thing to note is that the outcome has to be written like this or like this. It needs to be capitalized and it needs to be spelled correctly. The other thing to remember is that you need to use the random module in order for the errors to go away and for you to be able to generate random numbers. Now, one of the easiest ways of getting the computer to generate some random numbers or random sequences is by using something called a seed. If we give these mathematical equations something truly random to start with, then they can extrapolate from that and create random numbers or random sequences depending on what it is that we need. this seed can be any number of things. It could be the timings of your keystrokes when you're typing randomly on a keyboard, or it could be your mouse pointer movements, random directions and random speeds and random orientations to generate these random numbers. Or if you're, say, a state lottery, then you might use something a little bit more fancy, like looking at the decay pattern of something radioactive and using a Geiger counter to produce a seed to generate the lottery numbers. But of course, that means that if you know the seed, then you can pretty much work out what the numbers will be. So there's a really interesting story in the New York Times Magazine that I came across a while ago about the man who cracked the lottery. A guy who was able to modify the lottery number generator machine's code so that on the days when he was not working, he would get the lottery machine to use a seed that he knew. That means that he narrows down what could be potentially millions of different combinations of lottery numbers down to just a few hundred. And he won quite a few times in the lottery, but then he kind of got into trouble because he was doing something a little bit sketchy. But this is a really interesting, although illegal, application of pseudo-random number generation and the role of the seed. So I recommend taking a look at this article if you're interested. It's a really fascinating story. Now, do you remember earlier on when I was explaining about pseudo-random number generators, and I said that the random number generator for Python actually uses the current timestamp as the seed. But we can, in fact, change the seed to something that we want it to be. So, for example, I could say that instead of using the computer's clock time, let's use a number that I've just specified or pulled out of thin air, 1, 2, 3. So now when I hit enter, you'll see that my random integer is 1 and my random float is 1.338. The interesting thing about the seed is that if you specify the same seed, the random number that's going to be generated is always going to be the same. So let's try a different number, right? Let's try 321. Then we get different random numbers being generated. But if we go back to 1, 2, 3, then it's still 1 and 1.33. And if we go back to 3, 2, 1, then it's still going to be 5 and 1.95. When you run this code, it's going to ask you for a seed number, as you can see in the GIF here. And the reason why this is here is given that random number generators generate random numbers, it's very hard for us to check the outcome unless we can control which random number gets generated. So when we're testing it, we're going to be using a bunch of seed numbers that we came up with. But while you're testing your code and it's asking you for a seed number, then simply just type in a random bunch of numbers. And that is going to be used as the seed to generate your random number. So don't change the code on lines 4 to 7 and try to use what you've learned in the previous lesson to complete this challenge. So pause the video now and give that a go. All right, the first thing we're going to do, and in case you forget, then you're going to get errors such as undefined variable random, because that obviously comes from the random module. And once I've imported it into this project, then I can start using it and my errors will eventually go away. The next thing we need to do is to generate a random number, either a 0 or a 1, so that we can test which one we generated, and 1 means we output heads, 0 means we output tails. So below this line of code, I'm going to tap into that random module that I imported just now, and I'm going to use the randint function that we saw in the last lesson to generate a random number between 0 and 1, which pretty much just means I'm either going to get 0 from this function or I'm going to get 1, because there's really no other digits in between. So once I do get a result from this function, then I want to be able to store it inside a variable, which I'm going to call random side, the random side of the coin, right? And then I'm going to be able to check the random side and see if it's equal to 1, then it means I print heads. But else, or basically if it's not 1, then I'm going to print tails. So now I'm pretty much done with my code. Let's go ahead and hit run and just write a random number for the seed. And then we get tails, or if I use a different random number, then we might get tails again. I mean, it is random, right? Or we might get heads eventually. And I'm now done with this challenge. So how did you get on with it? If you got stuck, if you forgot how to do certain things, or if some parts of your code didn't work, or if you had errors, then this is the time to go back and fix it so that you actually understand what's going on and we can proceed. So once you're done, head over to the next lesson and we're going to learn about Python lists.